Hey, what's up guys? My name is Neil and welcome to the first part of my mirror networking series where we'll build a multiplayer game in Unity using mirror networking. So in this video we'll be setting up everything we need and we'll get a couple cubes moving at the end. I am assuming that you are familiar with C#, so if that's not the case, go ahead and learn that first, at least the basics. After that, we'll cover some networking fundamentals and go over things like the client-server model versus the peer-to-peer model. And we'll cover topics like sockets, TCP, UDP, reliable UDP, and so on. After that, we'll build a simple multiplayer game from start to finish, which includes all of the in-game mechanics and gameplay, as well as some of the back-end architecture needed for multiplayer games, like in-game chat and voice systems, matchmaking and lobby systems, databases, and how to deploy your game on various cloud platforms like AWS GameLift or Azure PlayFab. And we'll also go over a few other things like anti-cheat, integrating with Steam, and player hosting. If you need any help or want to join the community, you can check out our Discord link below. Alright, so you might be wondering why we're going to be using Mirror, and so let's just go over that really quickly. So Mirror is free and open source, so you can always go into the source code, make modifications, and just see how things are working under the hood. It's based on Unity's abandoned UNet networking system. But the developers have fixed a ton of bugs, they've added new features, and there's active development, so Mirror is constantly improving. Also, DOTS networking, which is Unity's sort of next phase of networking, is still, I'd say, at least a year away from being production ready. So I'd say in the meantime, Mirror is probably the way to go for any new projects. There's a large community around Mirror, and the documentation is really nice. And they have like an API reference and many examples. So definitely check that out. In Mirror, the client and server are both in the same project. And so this is a huge time saver because you don't need to, sync over your code or worry about multiple projects. Everything is just in one place. And so it's really nice and simple. Also, Mirror supports player hosting and dedicated servers, so depending on your budget and scale, you at least have options. Maybe you can start out with player hosting, and then if you have a lot of players or your game gets popular, you can move to dedicated servers, because you will get better performance with dedicated servers as opposed to players hosting games themselves. Okay, so the first thing we need to do is set up a new Unity project. So I'll go ahead and open up the Unity Hub. I am using Unity 2019.4, which is the latest LTS version. Do note that Mirror is only compatible with the 2018 and 2019 LTS versions of Unity. So if you're going to be using the 2020 release because you need a new feature or something like that, keep in mind that things are probably going to be broken with Mirror for the near future. But when you're watching this, things might be updated. So anyways, I'll name this our networking tutorial, and I'll save this on our desktop for now. So this will take a second to create. Okay, so once it's all loaded up, let's go ahead and head over to the asset store. So you can just go to Window, Asset Store, and give this a second to connect. And let's just search up Mirror. And it's free, by the way, so you don't have to pay anything for this. And go ahead and click Import and import that into your project. For now, let's just go ahead and import everything. Alright, so once it's imported, we can go into it, and you'll see that they have an examples folder. And this is really a really nice thing that they've done. If you ever need to, see examples of how they do different things, this can be a really nice place to see, some example code and dive into their samples. Alright, so the first thing I like to do in any multiplayer project is download this tool called ParrelSync. So they have a GitHub page right here. This was just made by somebody in the community. And what it is basically just an editor extension that allows you to have multiple Unity project windows open of the same project. And what it's doing under the hood is just creating a clone of your project and automatically syncing over changes from your main project to your clone. And so what this allows you to do is not have to rebuild your project every time you change something because you want to test out both the client and the server on your machine when you develop. So down in the installation directions, we just have to go to their releases page. And the latest version at the time of this recording is 1.4.1. So we'll go ahead and download the Unity package for this. And I'll save this. And back in Unity, we can go to Assets, Import Package, Custom Package, and find wherever you downloaded that and hit Open. And we'll import everything for now. Alright, so once it's imported, you'll see that we have a new menu option up here called ParrelSync. So go ahead and click on that and click on the Clones Manager. So this is where you manage your project clones and basically open up the second editor window. So we'll create a new clone of our project. Alright, so once the clone is made, you'll see that they give you the project path of it. And name it the same as your project and append like an underscore clone, underscore, and then the clone number. Anyway, so we'll go ahead and open this up in a new editor. And once that's open, you can see that we have two project windows open of our networking tutorial project and then our networking tutorial underscore clone underscore 0 project. And what's going on is that the changes from our networking tutorial project get automatically synced over to the clone. So let me just position these so that they're side by side. I'll move this up. Alright, so I can sort of demo this using one of the example projects in the mirror folder. So head over under examples. You can see they have a Pong example. So double click on that. Go into their scenes folder and then open up the scene for Pong. And let's do the same thing on the cloned project. So under mirror, examples, Pong, and then scenes, let's open up the Pong scene. Okay, so if we head over to the scene tab for both, you can see we've got the Pong board, I guess. And let's go ahead and hit play on both projects. And I'll maximize them both so you can see this better. Alright, so you can see that there's 3 buttons up here for hosting, becoming a client, and server only. So this is part of the default mirror UI. And basically what this means is that when you're hosting, your game client is acting as both the server and the client. So if you ever wanted to have player-hosted games, you would have like a player host a match. For a client, it'll just connect to the IP address you give it here, and localhost just means it's your own IP address. And then for server only, instead of hosting, like being a server and a client, this would be you're just acting as a server, so you can't really play your game. You're just hosting it. So for now, let's just go ahead and hit host on our clone. And you can see that it's saying that the server is active and it's running on port 7777. And then on our original project, let's go ahead and join localhost as a client. So it's already filled in for you, just hit client. And you can see that we've got a Pong game going. You can click on both games and sort of see it synced over and moving around. And this is the power of ParrelSync, right? You don't have to rebuild your project over and over. You can sort of just automatically have your changes synced over, and you won't believe how much time you can save like this. So let's go ahead and hit stop host here, and you'll see that it stops on both clients because the server is down now. And let's just get out of the play menu now. Okay, so I'm going to close the clone project because we won't really need that for now. And the next thing to do is set up VSCode. So VSCode, or Visual Studio Code, is the code editor that I like to use. but I know that many of you guys will be using Visual Studio or JetBrains Rider. It doesn't really matter, so feel free to use whatever you like. But if you are using VS Code like me, you'll want to pick up these extensions right here. So obviously the C# extension by Microsoft. The C# XML documentation comments extension comes really in handy when you want to document your code and add comments. Then the debugger for Unity, where you can connect Visual Studio Code to Unity to debug. And then lastly, the Unity Tools extension, which just has a bunch of random stuff that comes in handy. Okay, so for this project, I'm going to be using Git along with GitHub, which is just a version control system, so you can sort of see your past changes and also have a backup on the cloud of your entire project. And I strongly recommend that you do this for all of your other projects, just in case that you need to, revert your changes or your computer dies and you need a backup. Having this in place can be really helpful. So let's head over to the Git website. You can just search up git-scm.com. And you'll get here. And Git is just, if you don't already know, it's just a free and open source version control system made by the same guy who created Linux, Linus Torvalds. So just go ahead and download Git. You'll also want Git LFS. Git LFS allows you to version large files because in a typical Unity project, we have a lot of large binary files like 3D models, images, sound files, and so on. So again, the installation here is pretty straightforward. I don't want to waste your time with this. So go ahead and do that and come back when you're done. All right, so let's open up Visual Studio Code and I'll open up the integrated terminal and let's navigate to our project. So I'll just open that up and I save this on my desktop. I'll just open that. And the first thing we're going to do is type in git init to initialize our Git repository. And we're going to create two files, the .gitignore file, which tells Git what files we don't want to track in the version control system. And we'll also create a .gitAttributes file, which tells the Git LFS, large file storage, what we want to track as part of that. So for the gitignore, I'm just using a Unity template for this, which you can find on GitHub, or you could just actually copy over the gitignore I have. I'll have this entire project and repository linked below, and you can also copy over my Git attributes, which is just another template file that I found with a quick search on Google. So now once that's out of the way, let's go ahead and make our initial commit. So if you do git add dot, that'll add everything in our project to the Git system. And if you type in git status, you'll see that everything's green or being tracked. And we'll name our first commit our initial Unity project. Hit enter. And if we type in git log, we'll see that we have our first commit. Now let's head over to GitHub. And if you don't already, go ahead and create an account. But what we'll do is create a new repository. And I'll call this our networking tutorial. And I'll leave the description blank and make it public. And we're going to skip adding any of these README files or licenses or anything because we already have an existing repository that we want to push up to GitHub. So just go ahead and hit create. And once that's done, we're going to have to run a few commands. So copy over git remote at origin and then whatever your URL is. Head over to VS Code and paste that in. And once that's done, we're going to run git push -u origin master. And what that's going to do is push over our local project and upload everything up to GitHub. So give that a second to finish, and let's head over back to GitHub. And if we refresh this, we'll see that we have our entire project uploaded to GitHub. Okay, so now that this is all set up, let's head back to Unity. And we're still in our Pong scene, so let's go back to our default scene, and that's under Scenes, Sample Scene. And I'm actually going to rename this to Main. All right, so the first thing we're going to want to do is create an empty game object. So under create empty, and we'll rename this to Network Manager. And we'll add two components to this object. The first one being the network manager, and the second one being the network manager HUD, HUD. Go ahead and add that. And don't worry too much about these settings right now. We'll be going into all of this in a ton of depth later on. There's just a few settings that I want you to notice for now, and that is the network address, which is localhost, and the max connections, which is 4. So this basically means that the default address that's filled in that user interface from before is going to be localhost, and the max number of connections or players that we can have at any given time is going to be 4. Also, under the telepathy transport component, you'll see that there's a port option where the default is set to 7777. And this will obviously be changed later on when we talk about things like dedicated servers and stuff like that. But for now, just leave everything as is and don't worry too much about it for now. So let's also go ahead and right-click, create a 3D object, a cube. And we'll use a cube for our player object. So let's rename this to player. And we'll also create a material for this because I think gray is kind of boring. So under assets, I'll right-click, create folder, and we'll call this materials. And in materials, we'll do create material. And I'll just name this our player material for now. We can make our player green for now or something like that. This seems nice. And just drag that on to our player. Whoops. Drag that on. And create another folder in assets called prefabs, because we're going to turn this player object into a prefab. So just drag in your player object in the scene hierarchy down into the prefabs folder. And we'll go ahead and assign that to our network manager. So basically what we're doing here is using the player prefab we just created as the default player prefab for any players that join the game. And you can see that we've actually got this warning here saying that player prefab must have a network identity. And that's actually a nice warning because any object that's networked, such as our player object, needs to have a network identity component on it. So we'll go ahead and add the network identity component to it, and we'll apply that to the prefab. And let's try that again. So in Network Manager, drag in the player prefab from your project over to the player prefab. And we'll go ahead and delete the player object from the scene. So right-click and delete that. All right, so click on the player prefab and hit open prefab. And so for now, what we're going to do is add a simple movement script just so that we can see a couple cubes moving around. So let's create a scripts folder. Right-click, create folder, call it scripts. And right here, we'll just create a new C# script and call it player. Let's open that up. And let's go ahead and remove everything inside the class. So the first thing we're going to want to do is change this from a mono behavior to a network behavior. And to do that, we'll also have to import mirror. And the network behavior is pretty much a mono behavior, but with a lot of networking functionality added that's coming from mirror. So in the player class, let's go ahead and create a new method. Call it handle movement. And in here, we're going to check if the script is running on the local player, because we only want to use the local player's input for their movement, so that, one player doesn't control, somebody else's movement. So to do that, all we have to do is check if is local player. And this is just a field provided by the network behavior. And we'll go into all of this in a lot more depth later on. And in here, all we're going to check is whether the player is pressing down the up or down or the left or right keys. And so to do that, we'll create a new float called move horizontal. And we'll assign the value of input.getAxis horizontal to that. And similarly for move vertical, we'll get input.getAxis and vertical. And using these two values, we'll create a new vector3 called movement, and we'll assign the move horizontal to the x value of that vector, the move vertical to the y value of that vector, and we'll just assign 0 to the z value. And using this movement, we'll change the current position of our player cube according to the movement. So we'll assign it to transform.position plus movement. All right, and we'll create a new method called update, which is just run every frame. And in update, we'll just call handle movement. So this code will be run every frame if the script running this is on the local player object. And so back in Unity, let's go ahead and add this script to our player prefab. Let's head out of this prefab object, and if we hit play, we should be able to move our player object using WASD. So let's move it. We can see it's moving quite fast though, so maybe we want to turn that down. So let's just get out of play mode. And so let's head back to the player script, and maybe we want to turn these down by multiplying each of the floats here by 0.1. And now let's try that again. Yes, and it's saying we can't convert from a double to a float, so let's go back and add the F here to specify that these are floats. Head back to Unity, and let's try that again. All right, so if we hit host for now, we can see that we can move around our cube just fine. All right, now let's try ParrelSync again, so we can open this up in 2 different editors and see if everything is synced over. So click on Open a New Editor, and once it's opened up, let's close that, and I'll open up our scene again. So go back to Scenes and open up Main, and you can see that everything was actually synced over automatically. So now let's hit play on both the projects. And if I host from the clone and join from the client, let's see if we can see those cubes moving around. It's actually kind of hard to see, so let's get out of play mode. So let's move our camera maybe a little bit backwards. Let's just drag this back on the z-axis. Now let's hit play mode again on both. Again, we'll host, and I'll join in as a client. And you can see that when I'm moving around the cube on our original project, it's not really syncing over with the host. And the reason for this is because we didn't do anything to sync over the position. So let's go into the player prefab again, and we're going to add a new component called the network transform. And this just basically syncs over the position, rotation, and scale of our player object to the other clients. For now, we're going to select client authority here, and don't worry, I'll explain all of this stuff later. This is just to try to get a demo up and running. And so let's go ahead and save that and click on our clone project, and let's just double check that player prefab has the network transform, and it does. So again, working nicely with ParrelSync. And let's go ahead and click play on both the clone and our original project. All right, so I'm going to host from the clone. And it doesn't matter, by the way, where we host from. But anyways, let's join in as a client on this one. And now you can see that when I move around the player object on our original project, it's synced over on the clone. So it seems like it's being synced over properly. And you can see there's a slight delay if you really focus. It's like less than a second, a fraction of a second. And that's normal because in any network scenario, you can't get perfect syncing going on. So there will be a slight delay. And now let's click over here and make sure it's being synced, and it is. So it looks like we've just gotten our basic 2-cube example set up. You could say this is sort of like the hello world of multiplayer game development. But anyways, let's go ahead and exit play mode. Save everything, and just for the sake of it, we'll create another commit just for this. So let's go ahead and git status. So you can see a bunch of stuff has changed in our project. Let's go ahead and add everything using git add dot. And if we do git status, everything's added. So let's commit this and say hello world multiplayer edition. All right, git status. You can see we have one unpushed commit here. So let's just do git push. Now when we go back to GitHub and refresh the page, we'll see that we have two commits here. Our initial commit here for the Unity project and our Hello World Multiplayer Edition commit. So I'll post this in the description so that you guys can, look at the code and everything. But that just wraps about everything we need for the setup phase, at least, to build a multiplayer game. And in the next few videos, we'll go over many of the fundamental concepts in networking. I know in this video, we sort of just rushed along, adding components and stuff to get to that initial demo, but all of this stuff will be explained in depth in future videos. And I think it's really important to cover these networking concepts first to have a good understanding of, all the basics before jumping into building a game, because otherwise this kind of series can end up being a monkey see, monkey do experience, which is something I don't really want. Anyways, if you have any questions or got stuck anywhere, feel free to hop into our Discord and ask away. And please subscribe and drop a like if you thought this was useful. Thanks for watching, and see you next time.